Welcome back. In this lesson, I'll give you a quick introduction to SQL. SQL stands for Structured Query Language. You may also hear SQL pronounced as SQL. It's a programming language specifically created to interact with relational databases. That definition may seem a bit too simple, and you may want to understand a couple of terms better. Firstly, even though SQL is a programming language, it's a specific type of language called domain-specific language. I'll explain what a domain-specific language is shortly, but some of you may not be familiar with the term databases. So let's start with a high-level overview of databases. Databases are used to store data in an organized manner, and also they provide us with the capability to interact with the data as and when required. As you can imagine, data is everywhere. Data refers simply to any piece of information. For example, you are a student on my course. That's a piece of information important to me. I may want to keep a list of all the students enrolled in this course to help with my interactions. Similarly, you might have taken a number of online courses similar to this one. Again, that's a piece of information important for you. Data can even be as simple as a shopping list or a to-do list. They're all information or data that has value. So you might want to keep that information somewhere. My to-do list and the shopping list could be very small, so I might write them down in a physical notebook. You may want to keep the list of courses you're taking in a text pad in your laptop or mobile phone, as it's probably just a few entries. Assuming I have hundreds of students enrolled in my course, I may choose to keep the list of students in a spreadsheet. This gives me the ability to search and analyze the data quickly. For example, I'll be able to quickly find all the courses a particular student has enrolled in. Also, I can calculate the total number of students in a week, month, etc. I could simply update the spreadsheet manually every day. My spreadsheet may contain the student's personal details such as name, address, date of birth, etc. It may also contain information about the courses they have enrolled, the date of registration, and also it may have the student's credit card details using which the payment was made and the payment amount and so on. Imagine the course becomes popular and I get tens of thousands of students registering the course. It'll be impossible to manually capture this much information on a daily basis. So I may have to allow for my website to be able to directly update the spreadsheet every time a student enrolls in the course. Also, legally, I need to restrict access to this spreadsheet and keep it secure as it contains the personally identifiable information of my students as well as their credit card information. I also should be able to enable access to more people in my team to be able to concurrently access the spreadsheet so that they can use this data effectively for marketing and reporting purposes. Spreadsheets enable some of these capabilities such as shared access, password protection, etc. But it's far from what we need. This is where databases come in. They let us store large amount of data. We can define the security required so that only the authorized users or applications are accessing the data. They also enable concurrent access to the database tables so that multiple users can work on the same data. And they offer many more benefits such as data integrity, automated backups, quick access to the data, etc. Databases store data in the form of tables organized as rows and columns. But how do we access the data stored in a database table from a web application or as an individual user? That's where SQL comes in. SQL is a programming language specifically developed to interact with databases. But you might be wondering, how does a storage system such as a database understand a programming language such as SQL? You're not alone. A lot of people consider databases to be just a data storage solution. But there are two components in a database. The first one is the storage, which keeps the data we want to store, and that's what most people are familiar with. But it also comprises of another component called Database Management System, or abbreviated as DBMS. This is simply a software component, and that is the brain behind the database. It has many functions, such as processing the SQL statement being sent to the database to get the right data, managing access to the database, taking backups, optimizing the SQL statements to get the best performance, etc. We'll commonly refer to both of these components together as a database. Also, please note that when you're working with relational databases such as SQLite, MySQL, PostgreSQL, Oracle, etc., the database management system is referred to as Relational Database Management System, or RDBMS. Now that we understand what a database is, let's quickly talk about SQL. SQL is a domain-specific language specifically designed to work with databases. The opposite of domain-specific language is the general-purpose programming language, examples of which are C, C++, Java, etc. A general-purpose programming language can be used to perform a variety of tasks, whereas a domain-specific language is specifically developed to solve a specific problem. In this case, SQL is specifically developed to interact with databases. Another example of domain-specific language is HTML, which was specifically developed to create web documents. Even though domain-specific languages are limited in functionality, they have a major advantage that they're easier to learn and use, and SQL is no exception. In summary, SQL is a domain-specific programming language created specifically to interact with relational databases. You might now be wondering whether learning SQL on a specific database is sufficient to work on another database. The answer is broadly yes. Most databases adapt the standard for SQL defined by the American National Standards Institute, or ANSI, with some minor variations. So once you learn to work with SQL on one of the databases, you will be comfortable working with the others. Of course, there will be some small differences, but you will be able to easily work with them. Examples of some of the most common databases are PostgreSQL, MySQL, SQLite, and SQL as shown here. You can even use SQL to work with big data technologies as well as NoSQL databases, as most of them nowadays offer a SQL endpoint. I hope you now have a basic understanding about SQL and databases. In the forthcoming lessons, we'll delve deeper into its capabilities. And that's the end of this lesson. I'll see you in the next one.